Hey everyone, my name is Jack, and I'm the lead CAD designer on the Gator Vex Robotics Vex U team. In this video, I'm going to be showing you guys how to build a chassis just like this one in Fusion 360. It's going to be a very basic video, just kind of covering some basic assembly tools. So for those of you who've never used Fusion before, you should be able to follow along and build this with me. So you're going to start off by making a new design and then saving it. Save it wherever you want. I'm going to call this one chassis for video 3 because this is my third time trying this. So now I have a design with nothing in it, and so to start putting things in it like C channels, I'm going to go over to where I have my C channel stored. So if you're on the Gator team, you would be in this team right here where I have all this stuff stored. If you're not on our team, you can go and download a Fusion library that has all these Vex components in them, or you can go to the Vex website and download them piece by piece. So for regular Vex EDR stuff, you can get it all in a library. You don't have to worry about downloading individual C channels and stuff. But if you're on a Vex U team and you want to go grab some Vex Pro stuff, you can download them as step files and upload them using this button right here. So start off, I'm going to go to Structure, C channels is where I have all the C channels stored, and I'm going to use this 17.5-inch C channel. It's the 35-hole C channel. It's basically the longest one Vex sells, and it's the only one that we buy and use. We just buy them full length and then cut them up to whatever size we want. So once you have your C channel, I'm going to right click and then click on Insert into Current Design, and that's going to take this C channel component and link it into my design like this. So I'll be able to move it around, rotate it, do whatever I want with it, but it'll be here. So I got the first C channel. I'm going to add in a second one right now and try and line them up a little bit to how I want my chassis to start out with. So we'll make them face each other and spread them out like that. So these guys aren't actually connected at all. As you can see, I can move this one around. So to get the chassis started and to connect these two C channels, I'm going to use the joint command. And before I do that, if you moved your C channel around at all, it's going to ask you to capture the position. That basically means that if you use continue, it'll put your C channel back to the original spot before you started clicking and dragging it. If you do capture position, it'll start it out in the original position that it's in. So for our sakes, I'm just going to do capture position because it's going to make things easier. So you'll have this joint box up here that gives you a lot of different parameters. What we're going to focus on is these snap parameters where you choose a component. So for component 1, I'm going to go over here to my first C channel, and as you can see, it lets me select all these different points on the face. What I'm going to do to start out with is I want to choose the top face, so I'm not going to select a point, I'm just going to click on the face, and then that will allow me to click points on this face. So I'm going to click the center of this line right here at the very top of the C channel. So now I have the first point of the first component selected. Now it wants me to select the second point on the second component. So I'm going to go over to the other C channel, do the exact same thing, and choose the same top of the square hole. And that'll connect these two together. As you can see, these aren't lined up properly at all. So the first thing I'm going to do is undo this flip thing here, which will go ahead and line them up as if the 2 points were on top of each other. And then I'm going to use these joint alignment tools right here, these arrows, to spread them out whatever distance I want them to be from each other. So for this one, we're just gonna say 16 inches. So that's kind of standard. You might want to make it bigger, you might want to make it smaller, depends on your chassis. So we have that, and don't worry about what size you make it. You'll be able to go back and change it later. So now that you have these two C channels in your design and jointed together, you can add 2 more that are going to serve as the inside kind of rails for your chassis. So what I like to do is once I insert them, I'll rotate them and kind of put them close to where I want them to be. So like this one will go here, and then I'll insert the next one, and I'll put it over here like this. and that just helps me kind of keep track of things because I like to put a whole bunch of C channels in at once. But doing this lets me easily access the faces that I want to click on. So now that they're in here, I'm going to do the same joint command, capture position so they stay right there, and then I'm going to choose, I'll start out with this one. So for the first component, now that I have other components joined together, I'm always going to make the first component that I click on, this one right here, is going to be the newest thing that I inserted into the design. So it's basically going to be, once I do this one, just like that, same thing as before, I click the face and then the point. I'm going to choose that one first, so that way when I choose the next one, which will be this one over here, face and then point, it moves that second one, or it moves the first one to the second one. So you really, it's not a huge deal, but I like to always make sure that the second component that I'm choosing is like the main design that's already been jointed together. So same thing as before, it flipped it for us, so I'm going to have to undo that, and then I can use these arrow keys, the joint alignments, to put it wherever I want. For this one, I'm going to say 3 inches away, and you always want to, when you're using C channels, you want to do it in increments of 1/2 inch or 1 inch, because that's where your hole spacing's at. So if I did this at like, I don't know, 2.6, these holes wouldn't line up when I put a C channel across the thing. So always make sure you're doing it in 1/2 inch or 1 inch increments. So same thing again, I'm going to go over here, and I like to use the J key for joints, so you don't have to click this, you can just press J on your keyboard. So I'm going to go to the one that's kind of free floating, click that thing, that point, and then I'll go to the second one that's already been jointed, and I'll do the same thing where I do face and then point. And it's flipped again, so just undo the flip, and that'll bring it, it's sitting inside of the C channel now. So all I gotta do to move it is this. We'll do 3 inches again to keep everything symmetric. So now that you have the inside and outside C channels of your chassis, you're gonna have to add in 2 more to connect those together. So I'll go ahead and put in this one, just rotate around a little bit, make it a little easier, and then 1 more. Same thing, bring it over, rotate it. I'll show you, it doesn't really matter what angle or anything these C channels are at. They don't have to be lined up correctly at all, so I can use this one and go like this. And then same thing as before, click the joint. I'm going to make sure that I do the top hole here. Or, actually that doesn't matter, never mind. I'm going to do the face, and then the edge of the square, and I'm just going to come over to an arbitrary point, let's say right over here. So this is where that C channel is going to line up. And as you can see, it's not the direction that I want it to be in, so I can just take this and rotate it 90 degrees. See if that's correct. That is. Just look a little funky because that one's not 90. So that one's there. Great. I'm going to do the same thing with this one. Joint. Zoom in. Click the face. Click on a point. We'll do this one. Come back over here. Click on another point. So this guy also not in the correct orientation, so I'm just going to rotate him around 180 degrees this time, and it's all lined up. So, this one, so as you can see, it's not really symmetrical about this axis. This one is way too far back. So as you can see, the position of this one is not symmetrical with this one. This one's 5 holes too far back. So the nice thing that you can do in Fusion is you can just go and edit the previous joints that you made, either by right-clicking the joint here and doing Edit Joint, or going back to the timeline. So as I can see, this one is this corresponds to this joint here, and I can do the same thing. Click on it, Edit Joint. So if you know it's a joint that you just made that you want to go back and edit, you do it in the timeline. If it's one you made a long time ago, it's easier to just look here, and then you can hide these joints or show them using this little eyeball right here. So this one, I want to move it over 5 holes, so I'm going to right click, I'm going to do edit joint, and it's going to bring me back to this same joint box right here. So I'm just going to use this arrow here. I'm going to move it over 2.5 inches because that corresponds to 5 holes. Each hole's 1/2 inch. And now when I hit OK, the two joints, or the two C channels, are symmetric about the center of this center line right here. So now we have the base of our chassis, all the C channels that we're going to want to add, all 6 of them. But if you see here, these are sticking too far out. So we're going to have to go in and cut these. And the way to do that is with sketches and extrusions. So I'm going to use this right here to create a sketch. I'm going to make it on the face of one of these C channels. I'm going to choose this square right here. And that'll line me up with these faces. And I'm just going to create 2 rectangles for each C channel. So I got the 2 rectangles, and then you don't have to do this, but what I like to do is use the collinear constraint to make sure these boxes fit these C channels exactly. You don't really have to do this. You can just eyeball the rectangle if you want. But this one, I kind of like it because it gives me a little bit of peace of mind, and it makes sure that I'm not going to be cutting anything but that C channel. So I won't be accidentally cutting these. So get this going. One more. Alright, and then finish sketch. So what you may be thinking now is I'm going to use the extrude command to cut these, but there's something you have to do before you do that extrude. So like if I just went to try to extrude these, if I went to this one and I went to cut it, it won't let me cut it. If I do a cut, it's not cutting it, it's not doing anything. And the reason for that is because these C channels are still linked back to this right here, this other C channel model. And you can note, I know that because these little link symbols right here are on all 6 of them. So if I want to be able to cut these and edit these C channels independently, I have to break the link to this C channel here. So how I'm going to do that is I'm going to go to the tree right here. I'm going to select the C channel that I want to break the link, and I'm just going to choose break link. And when I do that, that little link icon goes away, and now I'm able to edit this without interfering with this C channel here. So I'm going to do it again with this guy, break link. And now both these C channels are their own components. They're not linked back to anything else. So this works both ways too. I could have gone and edited this C channel and changed the colors or done whatever, and that would have done that to, that will do that to all 4 of these C channels, but it won't make that change to these ones because they're now their own file. So now that these ones, now that the link is broken on these ones, I can go and use extrude, and I can click the 2 rectangles. And I also have to make sure to click this one because this is the part that I made the sketch on, and when I did that it projected this rectangle here. So just make sure you have the whole rectangle selected and there isn't a gap like that. So I have that, and what I'm going to do is go over to here, and instead of doing distance, where I can just type in a number and it'll do that many inches, I'm going to instead do to object. And what that lets me do is it lets me select a face or a body instead of giving a precise number. So I can go and select this face right here, and it'll cut these all the way up to that exact face. So I hit OK, and now my C channels are the correct size. The benefit of doing to object instead of just clicking this face while having it set to distance is that I can go back and edit this initial joint. So if I go back and edit this initial joint, it brings me back to the very, very beginning where we first align these 2 C channels. I can go and edit this to whatever size I want. We'll say 12 inches, just be a little crazy with it. And these 2 connecting C channels will always be to this face. They'll always be the correct size. So this means that you can prototype very fast by just changing a few parameters instead of going and redoing all your extrusions and stuff. So I'll bring this back to 16. And as you can see, they're still the correct length. So now that we got all that done, I'm going to start putting in some wheels, motors, and bearing flats. So I'm just going to go back to Vex. I'm going to start out with motors, so that would be electronics, and then V5 motor, same thing, insert into current design. There's my motor. I'm going to move it out of the way so I can see it a little bit better, and then rotate it so it's facing me. So now that I have my motor in here, I'm going to joint this motor to this C channel here, to the inside of it. So just like before, same thing, we're going to use joint. I'm going to go to this face, because this is these two faces are the ones that touch the C channel. I'm going to use the one in the center just because it kind of makes things slightly easier. You could do either one though, it's not really a big deal. And I also made sure that the motor is the first thing that I'm selecting, not the second, because I want the motor to move to the entire structure. So motor selected, now I just need to select the C channel. I'm going to come over to this inside one. Oops. And I'm just going to select, let's just say this hole here. And what I'm going to do is I'm going to make sure I choose this face, and I'm always going to choose this, either this top point here or the one on the bottom. I'm never going to choose the points on the side, and I'll explain that in a second. So I'm going to choose this top one, and that's going to line my motor up with that hole being centered on that top one. And in order to get it lined up correctly where I move it down, I'm going to use this arrow, and I'm going to do negative 0.091 inches. And that is exactly halfway between these two lines, so it's lining up your motor perfectly in the center. So the reason that I chose this top hole instead of a side one is now I can use this side arrow freely to adjust where I want the motor to be. So I can do it in, same thing as the C channels, you want to do it in iterations of 0.5 or 1 inch. So say I want it to be here, well that would just be 0, but I can also do negative 0.5 and it's still perfectly lined up. If I had chosen the side, you would have to combine the 0.5 with the 0.91, and it kind of gets into being a lot of math and really confusing. It's much better if you just do this top hole. So I'm going to keep it back to 0. I think that's where it's supposed to be. I might have to move it. Actually, I'm going to do this. I'm going to go back by 0.5. So I just hit OK. And now the motor is attached to the C channel. Just like that. So now that that's there, I'm going to go and add in a bearing flat. So that would be, for me, it'd be motion, bearings, bearing flat, insert into current design, bring it up here just so it's easy to see, and then move it so I can see the face that I want. So I'm going to be choosing, I just did joint again, and I'm going to be choosing this face, and then this center hole. Again, using the center just to keep it easy. You can do any of the 3 holes, really, doesn't really matter. So now what I'm going to do is, you would think I'd want to join it to this C channel and do the same thing I just did with the motor, but what I'm actually going to do is I'm going to join it to the motor, and you'll see why in a second. So I'm going to try and see if I can find this face of the motor that's touching the C channel. So that's this round face right here. It's the same one we used before. I'm going to click that face and then click that center hole on it. And what that does is it brings, I'm going to make sure to flip this. So that brings the bearing flat to the motor on this side of the C channel. But we want it to be on this one, so what we're just going to do is that same 3 inches, because we know these are already 3 inches apart. So by doing that, the bearing flat is in the right spot on the C channel, but it's connected to the motor. So now that we have the motor and the bearing flat together, we can start adding the wheels and sprockets or gears or whatever you want to put there. But the reason I made the bearing flat connected to the motor instead of the C channel is this. I can now go into this sketch or this joint right here, which was the joint that connects the motor to the C channel. And if I edit this to be, instead of 0.5, we'll say 1. Let's just move the motor way up here. Just being, I'll do 3 to keep it in terms of thing, but it's going to collide. But let's just say, when I do that, it brings the bearing flat with you. So if I put the bearing flat to the C channel, I'd have to edit both of those joints to keep them lined up. But by doing this, by making the bearing flat jointed to the motor, it keeps them linked together, so I only have to change this one joint. So I'll bring it back, where we have it 0.5, I think. Just like that. Now, I think let me see here. Oh yeah, so I'm going to move the bearing flat one hole over, just because I realized you want the motor to be, or you want the wheel, you want the shaft to be through the center of the bearing flat, not through one of the edges. So there you go, those are lined up. Now that the bearing flat's in here, we can easily add a motor, or not a motor, a wheel. So I'm gonna add the 4-inch Omni wheel. Bring it out of the way so I can see. Hit OK. And do the same thing with the joint. I'll select this face. Sometimes you can't select faces. Sometimes you just have to select like a line or a circle or like a ring. So I'm going to do this ring, and I'm going to come over to the bearing flat, choose this face, and then do this ring. So it looks like it's just part of the wheel, but the whole wheel's not coming along. But once I hit OK, the rest of the wheel will follow with it. And I'm going to say a 1/2 inch because I'm going to use a 1/2 inch spacer there. So you want to make sure you're doing your spacing in terms of, I think they up to an eighth of an inch, because that's what the spacers come in. So we'll say 1/2 inch because I'm going to put a 1/2 inch spacer. Now there's just barely clearance for the wheel, but it should be okay. And there's also just barely clearance. Actually, you're going to want to move something because these aren't going to want to go together. So that's fine though. All I got to do is edit this here. Oops. Oh. Didn't mean to do that. Gonna edit this joint. And we're just gonna go back to 0 instead of 0.5. And that'll bring the whole thing back because the wheel is linked to the bearing flat and the bearing flat's linked to the motor, which is linked to the C channel through that one joint. So it keeps it all together. And the last thing I'm gonna add just for fun is a sprocket, because a lot of people, us included, like to chain their wheels together to make sure they're perfectly synced up. So I'll go to sprocket and chain, get the small one, insert. It's going to be right there. I'll move it over so you can see it better. Joint. I'll click this ring just because it's there. Then I'll join it to the wheel. So we'll do that. I'm going to have to flip it so that it's on correctly. And then sometimes I just like to look at the top and then kind of eyeball while also using my increments of 1/8 or 0.125. So let's say 3/8, just to keep it simple. So now that we have all of that in order, they're all together, all jointed, and we make sure that everything's based off this single joint right here. That's the real key, is you want to make sure they're all based off that one joint. Instead of repeating that 3 more times, I'm basically going to copy and paste all of these using this new component feature. So instead of inserting another motor, sprocket, wheel, and bearing flat, all I have to do is click on this, say new component. I want to make sure it's empty. I'm going to name it drive pod. I'm going to make sure the parent is this thing at the top. I named it chassis for video. It's going to be whatever you named your chassis. I'm going to make sure it's not activated and it's not a sheet metal component. And I'm going to click OK. And what I just did there is I made a new component with no bodies in it. So it's going to act almost like a folder in Windows, if you want to think of it that way. Or I guess a folder in Windows or Mac, where I can take all of these. So I'll just control click these or shift click these. That's each of the 4 pieces that I use for drive. And I can just drag them and drop them into the drive pod. So I made sure to click on all of them. I'll hover over drive pod till it's highlighted and I'll let go. And now what that did is it put them all inside of this component. So if I selected this component, it would be all these things. And what the component does is it has all of those joints that were referencing the motor or the sprocket. They're all here. So what that means is it becomes its own self-contained subassembly. So all I have to do to make another one is just copy and paste. So I can go here, I can say copy, make sure I'm in the chassis, and then I can say paste. And what that does is it makes a whole new one. And by doing that, it keeps them all jointed together, so they're all their own sub-assembly. So now I can just take that sub-assembly, I can do the same thing I did before with the motor, where I do joint, I'm going to capture position, I'm going to click this face and find that point right there, and I'm going to join it to this other side of the chassis. So let's just say right here. Same thing, where I make sure I'm on the top of the square, and I'm going to say negative 0.091, so it comes down. Then I'm also going to rotate it because I want this hole here to be at the back of the chassis. So rotate it 180 degrees, or in this case it would be 0 because it was at 180. And then when I hit OK, it brings everything with it. Oh, I didn't. I did the rotation wrong. I think it was right before. Oh wait, no. Did I do something wrong? Oh, okay. I accidentally I jointed the wheel to the wrong hole in the bearing flat, and that's fine. That is actually a good thing right here because I can show how these components work. So I believe that's this joint right here. Let me see. Yes. So, oh, you know what? It wasn't that one. It's the bearing flat to the motor. When I went back to edit it and move it, I moved it in the wrong direction. I should have gone a ½ inch up instead of a ½ inch down. So that's fine. I'll just go, that's one of these. Let's see, whichever one came second. So I think not that one. Yeah. So this one, I'm going to edit the joint. Now I can see that's wrong. That's lined up wrong. That center hole is supposed to be lined up here. So I can just move it up, I think, 1 inch. Or a ½ inch. Yeah, ½ inch. And hit OK. And that fixes it. Now the wheel's in the correct spot. But what you'll notice too is now this wheel is also in the correct spot. So by going back and editing that joint, it edits the joint for both of these because they're the same subsystem, it's the same joint. So I can go and edit anything with these pieces here, and it'll reflect that same change in these pieces. So in that case, just because I did that, I'm going to have to move this wheel back because I don't want it to cross this this line here in the C channel. So that's fine. That's easy. I can just go to this joint, edit, and we're going to move the motor back 1 inch. So -1. Oh, wrong way. Just 1. There we go. There we go. That's where I want the wheel. So same thing, because this is jointed to the C channel, you're going to have to go back and re-edit this one. So yeah. No, this one. And a way to keep things from getting confusing, you can hide the joints in this thing. So now I don't see any of the joints in that are within this sub-assembly. So if you get them all right, you can hide them and then they're not in your way anymore. So let's go back to edit this one. Same thing, but this time it's going to be -1. So it moves up. And there we go. So I'm going to do the same thing 2 more times. Just put those on this side of the chassis, and we will have a 4-wheel drive chassis. So if you've used like SolidWorks or Inventor, a good way to think about the joint tool is it's just like the mate command in those 2 programs, but it constrains all 6 degrees of motion at once if you use the rigid joints. Now you can get into a little bit more advanced stuff with this motion thing where it starts to constrain less than the 6, but to keep it simple, we're just going to be working with rigid joints. And then you can also get into these things between 2 faces and 2 edge intersections and get more advanced with it, but we're just going to stick with the regular simple mode. Alright, so now I got my 4 wheels all installed. Each drive pod's ready to go. If I change anything on one of these, it reflects that same change to all 4 of them. So again, kind of helps you streamline your prototyping and your design process. So now that that's all done, you're basically ready to go, but I'm also, just for fun, I'm going to add some standoffs and then also use this new component tool to help organize all this stuff. So actually I'll do that now. So this isn't very messy as it is right now, to be honest. But if you wanted to clean up this part, especially when you start getting it, it's so long that it goes past here and you have to scroll. It helps to have it all kind of contained. So you can use the new component tool to create subassemblies and help keep this organized. So I'm just going to make one called, just call it base, or maybe you want to name it C channels or something like that. But we'll call it base, and then what we're going to do is take all of these C channels, I'm just going to shift click these, and then drag them into the base. So now they're all in their own subassembly called base with the same thing with all their own joints. So I can hide this and hide, see there's joints here and now they're gone. Helps you keep the joints kind of cleaned up and helps keep this nice and organized. And if you want to take it to another level, you could put all the drive pods in one and name that drive or something like that, or have one for electronics or something else. But just helps you keep organized, especially in big assemblies. It's really helpful. So all that's done. Last thing I'm gonna do is add some standoffs, because a real chassis would probably have those. But besides that, we're basically done. So do that real quick with 3-inch standoffs. Actually, let's do this. So what I like to do sometimes is, if I know how many of something I'm going to use, like this standoff, I know I'm going to use 8 standoffs because it's 2 for each drive pod. So what I'll do is I'll just copy and paste this 7 times. So copy and paste, enter, Control V, enter, and I'll just keep doing that. One more. And now what I can do is J for joint. I'm using the keyboard. Click it, come here, wait for it. I might have to zoom in a little. You might have to zoom in sometimes. There we go. Bring that down. Same thing with the motor, where you go negative, or this case it'd be positive 0.091. And then I'm just going to flip it. And I have a standoff there. Something funny you'll notice, the standoffs come through these C channels, and that's because they don't actually perfectly line up. You might have already realized that when trying to build your chassis in person or in real life. So the fix to this is usually just kind of, for us with Vex U, we don't actually use these standoffs here. But if you want, you can actually use a spacer and the standoff instead and get the spacing correct that way, or just kind of force your C channels into fitting that way. But if you could do it another way instead of using standoffs, I'd recommend that. But just for the sake of the video, and to make this look nice, I'll be using standoffs. Something else that might happen is you're gonna try to joint something, and you can't see it for whatever reason, like a motor's blocking it, or a wheel is blocking it, or a C channel's blocking it. And an easy way to fix that is to just use the show and hide command, I guess. And so you can either click the little eyeball up here to hide something, or we'll do this. So like if I wanted to hide the whole base to see a piece here, I could do that. Or what you can do is double click on any component and then just press V. And what V is just a shortcut to the same command, but just for that component. So I can hide it and show it like that. And once I do that, I can just either go back and find it in base, show it again, or I can hide it real quick just to see something, and then Control Z, undo, and it'll show it again. Alright, so now we're basically finished. I got all the standoffs in, and I'm going to do the same thing I did before, where I do new component, and I'm just going to name it standoffs. I'll fix that, make it look pretty. So same thing, new component. I'm going to shift click all of these because I know they're together. Drag and drop, and there you go. One thing to keep note is, here, I'm just going to undo that. You have to make sure your timeline's all the way to the right. The timeline is this thing down here. It shows you everything that you do. Basically, it keeps track of it. So if I were to say move the timeline to here, and then I made the new component, and I went to like drag this in here, it won't let me. And that's because there's some things to the right of the timeline that are grayed out. And I don't know exactly why. Here, I'm just going to undo that. I don't know exactly why Fusion does this, but I'm sure it's to keep you from messing something else up. So just make sure to remember that if it's not working when you try to drag, you have to bring your timeline to the right. So either just delete everything that was to the right of your timeline if it's not important, or go back to the most recent point on the timeline. So I'm going to shift click these, drag them in there, and see how it lets me now. Boom. Ready to go. And I can now access all the standoffs here. So that's basically it for the tutorial. I hope this helps some of you guys who are new to Fusion. If anything, take away the fact that you can use the joint tool, and it's just like using the mate tool in Inventor and SolidWorks, and that you can use the new component tool to create subassemblies to speed up your workflow and to keep this side of your screen organized. If you have any questions about this stuff, just leave a comment. This is my first time doing this kind of thing, so I hope it all went well for you guys. If not, leave a comment about that too. Say how I can improve on this, or if I missed something, or something else like that. So a few of us on the University of Florida team, Gator, are looking to kind of make some more videos like this for our new members, and for just anyone getting started with Vex, specifically videos in Fusion. So if you guys have any other stuff you want to see us make, or any of these functions you want us to go over, just let us know. Anyway, thanks guys. Hope you found this helpful.